Hey everybody, I am here for day 7 of the Advent of Code. Um, I've been having a lot of fun doing this stuff. It's great getting all of your input. Lots of the comments have been really helpful, and I've enjoyed responding to you. So thank you very much for that. Given that, I think we should just get started with the problem. Right? Is start working on it and see what we got here. So I think we made it to Desert Island, right? After we beat the boat ride, that was from yesterday. So let's continue on. Day 7 is camel cards. Your all expense paid trip turns out to be a one-way 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, louder this time. You aren't sure what part she's looking for. You're here to figure out why the sand stopped. The parts for the sand, yes. Come with me, I'll show you. She beckons you onto the camel. After riding a bit across the sand of the desert island, you can see what looks like very large rocks covering half of the horizon. The elf explains that the rocks are all along the part of the desert that is directly above Island, making it hard to even get there. Normally they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. Okay. You've already assumed it'll be your job to figure out why the parts stopped. When she asks if you can help, you agree automatically. Because the journey will take a few days, she offers to teach you the game of camel cards. Okay. As I was reading it, I was like, this doesn't sound like a card game. It sounds like some kind of puzzle game, block game. But it sounds like maybe this will be coming. We can look forward to some kind of puzzle block game. Anyway, so because it'll be a 3-day journey, Camel Cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. In Camel Cards, you get a list of hands, and your goal is to order them based on the strength of each hand. Okay, so like sorting your hands. A hand consists of 5 cards labeled Ace, Queen, Jack, 10 to 2. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Okay, yeah, that's like normal poker. Every hand is exactly one type. From strongest to weakest, there are 5 of a kind. Okay, that's not real poker. 4 of a kind. Full house. Okay, so that's 3 plus 3 of a kind and 2 of a kind. 3 of a kind, 2 pair, 1 pair, and a high card. Interesting. So they don't have any of the straights or anything like that. 5, 4, full, 3, 2 pair, 1 pair, high card. Okay. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. If 2 hands have the same type, a second ordering takes effect. Start by comparing the first card in each hand. Okay, so not the high card like you would in traditional poker. The first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. If the first card in each hand is the same, however, then move on to considering the second. Okay, so the way that they're describing this is more of like lexicographical sorting, right? So like 2, 3, 4, 5, and you just start at the beginning and move forward. Yeah, so 3, 3, 3, 2, and 2 AAA are both 4 of a kind hands, but 3, 3, 3, 3, 2 is stronger because its first card is stronger. So like 3 is greater than 2. In traditional poker, this would win. But in camel cards, this wins because they're both 4 of a kind, but the 3 is higher. These two are full houses. This one wins, although this one would win in poker, right? So in normal poker. But this one's stronger because the 8 comes first, right? So 7, you're pairing 7 and 8, and they don't. Okay, to play camel cards, you're given a list of hands and their corresponding bid, your puzzle input. For example, you have your hand and a bid, which is just a digit, looks like. This example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest 2, and so on and so forth. Okay, this is where the sorting goes in. So we're probably going to sort. We're sorting from lowest to highest here. Because there are 5 hands in this example, the strongest hand will rank 5 and its bid will be multiplied by 5, yeah. Okay, so the first step is to put the hands in order of strength. This one and this one are both, so those are 2 pair. The first cards are the same level, the second is stronger, so this one gets rank 2, this one gets rank 3. Yeah, so they've sorted these, and then we're going to multiply these and then sum them up, I presume. Now you can determine the total winnings of the set of hands by adding the results of multiplying each hand's bid with its rank. This times 1, this times 2, times 3, 4, 5. What are the total winnings is what it's asking. Yeah, so just to summarize, we have a sorting problem on this thing. We want to sort them in ascending order. And then we're going to take the bid values of them after they're in sorted order and multiply them by their rank, starting at 1. Right? Gets rank 1. Yes, yeah, starting at 1. And then add all those together to get a total number. And we have a fair number of hands. Okay, so this is just a sorting problem at its essence, and then you're going to do some work to figure it out. So the 2 sortings that are interesting are, I guess there's going to be a 2-tiered approach to our sorting. First, we want to kind of pick, sort this way. So my initial thinking is like each of these should have a value, and so we should be able to create a quote-unquote hand structure, and we can ask it a question. We can ask the question is, what is the rank of the hand, or what is the type of the hand, I guess is what it's using here. But the idea is this will be worth like 1, 2, 3, 4, 5, 6. Actually, yeah, we'll give each of these a rank and sort them all by that. And then any of them that are the same will go to a second one, a second ranking where we say, okay, well, now we just strictly do lexicographic this way. Although the ranking looks like this. So we can't strictly use numbers, although we could potentially translate these into their equivalent digits. In fact, that might be a good idea because we actually don't care about whether it's an ace or a king or a queen. We just care that it's, 10, 11, 12, 13, 14. That would make it easy to do that. So those are the things that are going through my mind. I think what we ought to do is just start programming it and see what it looks like. So let's get the test input. That's always helpful. And I'll zoom in here so we can see what's going on. We'll put that in there. We'll also do the... that's funny. I can't do the input because I do a fuzzy find on my thing. That's both hilarious and silly. I will have to try and fix that in my editor. Okay, but we got them both in there. So let's start thinking about what they look like. Again, I think we want to treat these as numbers. And so we actually, maybe we can create like a card. And I'm thinking, should we do it as an enumeration, like an enum, or should we do it as like just turn these into digits? It's probably easier. It's probably going to be easier and faster to do these as digits, because the way I'm thinking, here's what's coming here. I know I'm rambling on. I'm sorry, but here's the thing. The thoughts that I'm having is why it will be okay to be a number and why it's actually good. Notice we're only matching like pairwise operations, like 5 of a kind, 4 of a kind, 3 and 2 of a kind for a full house, 3 of a kind, 2 pair, 1 pair. So it's pretty easy to do like a mapping of these and just say, like, the way you'll know there's 5 of a kind is if you like dump all the cards into a map, and then you can say, oh well, I only have like a lane of 1 in the map, meaning all 5 of them have been like smushed into a single entry into the map. Same thing with 4 of a kind. We now say, oh, there's 2 different ones. So now I just check, is it 4 and 1 or is it 3 and 2 for 4 of a kind versus full house. 3 of a kind would mean you have 3 distinct numbers. Oh, that's probably the better way to say it. How many distinct numbers are in the list, and you do that, you could easily figure that out with a map, right? Here you'd only have 1 distinct card. Here you'd have 2. Here you'd have 2 as well, so you want the count of each. In this case, you'd have a 4-1. In this case, you'd have a 3-2. When you're doing 3 of a kind, you would have a 3, a 1, and a 1. You would not have a 3 and a 2 because that would be handled here. For 2 pair, you would have a 2, and a 1. For 1 pair, you'd have 2, 1, 1, 1. And then for a high card, you'd have 5 distinct values. So because you can like throw them into a map, and then I think it'll be easy to sort the numbers that way. I'd like to just translate all these into numbers. So a hand would actually just look like, if we just did a struct hand, we will have the cards, but they'll just be a vec of U8. And then we'll have the bid, which is a U size. I don't know how big the bids are, but we can just do a U size to start. And then we can use nom again. This one's relatively easy to parse, though. Maybe we don't even have to use nom. I did import it. I don't feel like nom is going to help us here. So let's just do it as a vec of U8 for the cards, and the bid is a U size. We'll hand those to our new function. Actually, for our new function, let's call parse. Let's create a parse function where we get string, and that's going to return a self. This one should return a self as well. Cards bid. So how does the parse work? We're just going to say let parts equal, split by white space collect. And then we'll say the bid is actually parts 1. And the cards are going to be parts 0 dot cars dot map. Oh, that's an interesting way to turn it into a U8, but we do need to see. Like, that won't work for all of them. What it's trying to do is say, oh, just take the character and subtract it from the 0th value. The idea being this is the equivalent of calling like parse usize on it, but you know it's a single digit, so you can just subtract it from 0. What I actually want to do is like have a fn car to value, and you can say like if c t else we can, let's use a match c. There you go, perfect. So we say 10 becomes 10, jack becomes 11, queen 12, king 13, ace 14. Otherwise, they have their own value, which is c minus c is u8. So down here then, we're gonna just do call hand car to value on each character and collect it. So I don't even need this part right here. Right, so now I have them both and I can just return that. Okay, let's try that. We'll read from input, and then for each of the lines, we'll just call hand.parse, and that'll give us a thing, and then we can debug hands. Although we'll have to now do derive. I don't know why I put that on multiple lines. We can do it like that. Oh, that's a good idea. Use a byte literal instead. Does it work? Oh, I'm doing it on input, so there's a bunch of them. Let's just do it on test input to start. What does the test input look like? So the first hand is 3, 2, 10, 3 king, which is 13. Yeah, ace is 14. This is 13. Bid 70, 65. 10, 5, 5, 11, 5. Jack is 11. Yeah. Okay. I think that's, I mean, it is not using nom, which I've been learning about, but I think this is simple enough that there's probably not need to use it. So now that we have our hands of our cards, we want to implement the sort function. So just to review that in Rust, Rust sort. Traits maybe. It wants you to do the comp, I believe. Implementation as a consumer partial order implementations. Like, I'm wondering what I have to do here, and I think it's ord. Ord stands for order. So like, can I order, given 2, can I do an ordering of these? And that's what I'd like to do here. So if we impl ord for hand, I don't need to sort the cards or the things. This is not useful at all. But let's, what will this thing look like? It's not going to compile at first, but we can say like if self dot cards, or what would it be? Self dot. First of all, we want to do the type. That's so if the hand type is, I was gonna say greater than the hand type, so how about we do comp hand type. So if we're gonna have some function that's going to compare my own type with this other type, we're going to, ooh, I should do it in a match, actually. Sorry, I'm trying to figure this out as I go. So if we do a match and they are equal, then we want to do the, we want to compare the hand like the lexical graphical order. Oh, but I can do that with just like that. And in any other case, I'm gonna return other. Is that it? Is it really? Oh, I'm missing a. The trait standard comp equal is not satisfied with hand. I think I just need to do part equal and partial equal. Why is it mad about this? Partial OR is not implemented. Maybe it. Oh, it does have to have equal and partial comp. Maybe it's partial ORed that I need to implement. Where T is ORed. Yeah, I know. I have to do partial ORed as well. But I guess I just only have to implement one more function. This partial comp. Okay, so we'll do that one as well. So the ordering will produce less, equal, or greater. So it feels like ORed can just do partial ORed, right? So can I not just do this here and then do this here? Because I'll never not have an optional. So I just say if I compare the hand types and they're this, I'm going to do self cards comp This will always be a sum. This will also always be a sum. What it's saying is the reason why it's an option, it looks like, is because it's possible for you to not do a comparison. Like for floats, you couldn't, not a number, you couldn't compare it to 1. These are not comparable, so it would want you to return a none. But that's never the case for me. So basically, partial ORed is just saying, I'm just going to say, hey, if they're equal, I need to check lower. I need to do a strict comp of the cards. And in that case, though, again, it's lexicographical, so I can just go da 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 da. And so I don't need to do anything special for this function. The one function I do need to create, though, is comp hand type, and that's where I want to derive, or I want to determine which of these it is. Oh, no, I can do a hand type. 5, 4. I can just do, it actually will look like this. Self dot hand type. Dot comp with other dot hand type. So I'm good. This is going to produce a number. So we'll let's see. Let's impl down here. We'll have a hand type function. And it will return a U8. For now, we'll just have it return 0. But so we can ignore it for now. But essentially the idea is, we'll say if this hand, we're going to do a comparison of this hand type to the other hand type. And if they're equal, then we will return comparing them, the cards from left to right. Otherwise, if they're less than or greater than, we just return that value, right? So if one is clearly better than the other, we just return that one that we have. Okay, what are we still not getting here? I need to do partial equal, which is easy to do. No method hand type reference hand. Oh, I don't have self on here, so it doesn't know that that's the type it is. Oh, it looks like Clippy is saying you actually should do it the other way around. Sorry, I was just reading this. It's saying, actually, the way you should do this is you should do a comp and then just do some of it. So it wants you to do this down here and this down here. We'll do a sum. And we don't have to unwrap. And now these are not sums. Okay, the code's going to look ugly for a second, but we'll fix that. Oh, and it's just a comp. There you go. Okay, yeah. So Clippy wanted you to do it that way. If you implement yourself both partial ORed and ORed, you should do ORed first and then partial ORed afterwards, I think is what it's saying. Which makes sense if you think about it, right? It's like, partial OR is always going to be a sum in this case, so I just solve it here and then do it up here. You'd probably still do it if it wasn't always this, but like you'd say, oh, I'm going to do this. No, you wouldn't. You have to do it the other way around for the partial. Well, the unwrap. I guess if there's ever a case where it was a none, you'd have to implement both, right? Or maybe you just say that type doesn't implement OR. Anyway, we're getting lost in the woods here. So now this will do our ordering, right? We'll do this thing and it will actually do the sorting for us as long as we can determine the hand type, right? And so this is where I think we want to turn them into a map really quick. It's not super efficient. But that's still doing it as an array. I want to do it like I think I've done this before where there's like a insert OR. Like this. Although it's not quite like that. We can clean it up later, but we'll do it like this. Hash map new. And then we'll say this will have to be a mute, and then we'll say self dot cards dot iter dot for each map entry insert. Okay, got the first line which I wanted, but I don't know if these are it. So this first part, what I'm saying is create a hash map, and then for each of the entries, I'm going to either increment it by 1 or, well, I'm always going to increment it by 1, but if the entry is not there, I insert a 0 and then increment by 1. This is what I was looking for. I've used this before where the idea is maybe it's not there yet, and so you can do this entry or insert to put an initial value there, and then you always increment. So now we just ask ourselves, what do we ask ourselves? I think we had already kind of figured it out. If there's only one entry, we give it a 5. So actually, 1, 2, 3, 4, 5, 6, 7. There's 7 types, so we give 5 of a kind to 7. So we'll just say match mapling, and 7, or let's see, 1 goes to 7. 2 could be this case or this case, so we need to determine if what the counts are. For 2. So we'll say 2 So if it's 4, then it's 4 of a kind, which would be 6. And if it is 3, it would be a full house, which is 5. Okay. So now if it's 3, that's this one and this one. So what is the difference between these two? It is the highest value is 3. So we're going to do the same thing, but we're going to get 3 and 2. And that will be 4 and 3. And then one pair, the highest value is 2. Oh, but it won't matter. This one will have 1. This one will have 4. So 4 goes to 2. Otherwise, you get 1. Okay, that's really big and a little hard to see. I guess these can just be underscores right here, because you'll only ever get 4 or 3. And so we'll just say anything else is. I can put this up here and then maybe clean it up a little bit. So now in this case, I just do this. And in this case, I can do the same thing. I can just go like that and like that. So that looks a little bit cleaner. Basically, this is not super efficient. I mean, maybe it may be efficient because there's only 5, right? The idea is we're just going to get a count of each of them. I don't, the map, this may be just as fast as you like doing an array and then checking the arrays. It looks cleaner to me though, right? Is you say, oh, I'm going to create a map of all the card entries. And so now I have a count of each card type. And then I'm going to get the max value from it for these special cases where they both would have 3 total. And then I can just do this match, right? I can just say, hey, if there's only 1 item in the map, that means it's clearly a 5 of a kind. If there's 5 items in the map, then clearly that's 1 of each. All of them are unique, so that's the bottom level. And then these ones I have special cases for where I say, oh, if there's only 2 of them, it could either be 4 or 3 of a kind. Or 4 of a kind or full house. And in the case of full house, it would be this. The high value would be, it would be 6. It would be 4. Would be, no, 4 of a kind would have 4 cards in the highest valued card, right? Sorry, I don't think I'm explaining that well. I've been getting good sleep. But the idea is you have this. There's 4 A's, so this would be 4, and that would be high. That would score higher than if it were 3 A's versus or whatever. Okay. Okay, so with that, we now should be able to sort them and then do the math. So how do you do a sort? Well, we actually want to do a mute on this now, and we'll call hands.sort, and then we will iterate on them, and multiply them by their rank and sum them up, right? So we'll do hands dot iter dot enumerate enumerate, and then we'll do map IH. It won't be a print line, but that will get us closer. Actually, we don't need the hand at this point, do we? We need the bid. So we do need it. It will be I plus 1 times h dot bid, and then we'll sum those up to get a U size, and we can then print line P1. $64.40. Okay, that works for the test input. So let's try the regular input. That is a giant number. That is the right answer. We did it. Okay, so just to recap, how does that work? So if you're curious, most languages like this have some way for you to say, hey, here's how I sort it. Like in Go, you can give it a function that says, hey, here's how I sort it. For Rust, you say, I need to implement these ORed and partial ORed things to sort it. And basically what you're just doing is you're given the two values and you tell me, is it greater than or less than? And in our case, if it's greater than or less than, we can just can just return it. If they're equal, though, we need to do a second level sort, right? And the second level sort was this part of the paragraph here where we're just going from the beginning to the end, right? So because we had to do the second level sort, we had to do something kind of funky like this, and then the hand type was this sort. I don't think it was particularly tough, but there you go. I mean, it did take me 42 minutes to get there, but it would be fun maybe one time. What I'll do, if you're interested in this, is just like do a heads down, how fast can I solve the problem? I suppose I could probably solve it faster if I'm just like, oh, I just got to get it done. But anyway, there's part 1. So let's move on to part 2. To make things a little more interesting, the elf introduces one additional rule. Now J cards are jokers, wild cards that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual cards, weaker even than 2. The other cards stay in the same order. Okay. J cards can pretend to be whatever card is best for the purpose of determining the hand type. For example, QJJQ is now considered 4 of a kind. Yeah, because you'd want to make these queens now. However, for the purpose of breaking ties between two hands of the same type, J is always treated as J, not the card it's pretending to be. So JKKK 2 is weaker than Q because J is weaker than Q. Okay, I was thinking this wouldn't be hard at first. At least this part is not hard right here, where we're just determining. I think it's pretty easy to find which one it is because we do the mapping and we just say, oh, well, like for example, what we just do for part 2 is we do something very similar to this right here. But when we're iterating over the cards, we probably do like a map right here where we say if it's a... It's actually after we do this is we say we now have the mapping. What we actually want to do is now find the highest one that's not a joker and turn it into that thing. So like say it's queens, we would eventually find the queen that has the most, and we'd flip it over there. We run into a sorting issue though, because now if a jack is at the beginning, it's weaker than all the queens. So we can't do this like strict sorting right here, because the value of joker is now less. Although we can do this card a value lower. I kind of just want to copy and paste what I have, and call it like the Joker version, and get a new thing. Let's start with that, and then we can. I don't know how these partial comps would work. I mean, we could also just say, oh, we're going to introduce a variable like Joker's bool, and that like changes how these things work. Should we try it that way? Sure. How does that look? So we now have this thing, and then when we parse it, you need to give it a Joker's bool. We'll put that in there. Right now, let's just ignore it. And let's see if it still works for part 1. Yes. I think that was it. 248-179. 786. Okay. So that doesn't change it. But what happens now when it's a joker? What do we do for our sortings? So we obviously need to change the hand type function. But we also need to change this because that might be easily changed. Where do we call this car to value? We call it here. Oh, we do know the Joker. We do know the Joker input here. So so we can just pass a Joker bool, and this one will be match Joker. If it's false, it's this. If it's not, it's a 1. So it's now of like lower value, and so this card of value would actually be okay. So that's that part. So we're saying as we're parsing it, we'll know whether or not we're playing the Joker's version of the game, and if we are, the Joker's is now a 1 as opposed to 11. So now it does. So now this comp does sort properly, right? We have some. We can, in the case of like the JKK2, this part right here, J is now less than this because J is weaker than Q. Right? It says J cards are now the weakest individual cards, right? So it goes below the 2, which makes it a 1. Okay, so now all we have to fix is the hand type, where we say we're doing this ordering, And so how do we fix this? I really believe... How much do I have to think about this? Because we're only doing pairs like that, like if you were doing traditional poker, the joker may be better to be like, say for example, you're going for a royal flush. Obviously, you'd want the jack to like fill what you're missing in your royal flush. In this case, though, because you're literally only doing pairs, right? You're only doing like pairings, kinds, sets, or whatever. You're always going to want to pick the highest one. So if you have 2 pair, just pick one at random, and now it becomes a full house. Yeah, you'd never... 2 pair always becomes a full house. 1 pair becomes 3 of a kind. Oh, that is interesting. 1 pair... You still pick the highest there. 1 pair, you'd pick 3 of a kind. It would go higher. A high card, you just pick a random one, right? 1 pair would become... The best you could do is by taking one of your pairs and adding another to it. 2 pair, you add 1 to it, and now it becomes 3 of a kind. Yeah, so I guess all of that talk is me saying I think what we want to do is find the non-joker with the highest value, and then the joker becomes that highest one, right? So that is just like this part differs between the two of them. So we can say like if self.jokers, we're going to do it some fun way. Otherwise, we're going to do it this way. And we'll see, maybe it looks slightly different. That is a first good step, though, right? Is we're going to insert all the numbers, and except for the jokers. But I do want to keep a count. Let that. Okay. I mean, that works. We could count it in here too, but this is also just saying where it's a 1 as well. That works. I think, oops. Why is it double dereference? What am I storing in here? Vacuate. Oh, I'm iterating and then filtering, so I got double. Okay. So how do we find the max? We'll do self.car, or no, map.iter I want both the key and the value, right? So, is there a max by value? No, there's not. I don't want the max by key. I want the max by value. But I want the key that's the largest. It would be like this: let largest and let largest value equals 0. I guess we just start them both out at 0. We'll eventually find them. But we say like if the value is greater than the largest is that, the largest value is that, that. So now we have like the largest and the largest value, and we can just do map largest plus equals joker count. Borrow. We want to borrow. Oh, these are switched. What type is mismatch? Expected do this value. Expected integer found. Oh, I need to dereference twice. Like that? Is that going to work better? I don't want to insert, actually. I want to update. This is just... These are the things about Rust that I haven't quite figured out yet, even though I've been doing this for a few years. It's like this thing right here. Why isn't... Can I just do this right here, I guess? Oh, I do have to dereference because I'm doing it plus joker count. It's the same thing. Largest does not live long enough. Is there a map update? Someone who's more rusty than me. Oh, look, this guy is having the same issue. Okay, so because it doesn't have an index mute, you actually do have to do it this way. There's something about Rust that I'm missing here. So, what it wants me to do is put it like up here, I think. And then it says I'll magically work. Yeah, okay. I don't quite understand that. I mean, obviously, part of it it's the borrow checker, right? It's saying something about largest that I'm not quite understanding why it wouldn't be able to just why a clone wouldn't work or just the value, but okay. I think I've got it there though. Okay, sorry about the interruption. That is life though. And I do like doing these like live, not cut. I think I've said that before, so even though I'm not like actually live, it's kind of fun to do the whole thing. This one's going to be long, but I think this does it, right? We say like if we're not a joker, we just do this. If we are doing a joker thing, find the joker count and then do all the cards but the joker. Then we find the one with the largest value, and if it happens to be one, we add that to the list, and now we can do our normal stuff here where we sort by it. So I'm tempted to try this for part 2 with the test input, and it will look the same, except we'll go true for the thing, and then we'll sort them, and then we'll do the listing like that. Oh, this will now be P2. 5905, was that where we got for the second part? 5905, okay. So let's try it with the whole input. See if there's not some kind of magic here. And there is not. Okay, so there we go. There is day 7. I do, though, again, like to spend some time. I realize we've been doing this for an hour, though. Kind of just looking at it and seeing what the solution was, what it looks like. This stuff looks pretty straightforward, this code, right? We're just like taking all the lines, we're turning them into hands, we're sorting them, and then we can enumerate to get the solution. So that stuff doesn't look too bad. The hand type I would like to look at. The parse, that feels okay. We're just kind of going through the different pieces. Or we're splitting by the pieces, and then we're creating our hand and our bid and making a new hand. I don't know how I feel. There's an about just having a joker's bool. So, like, what are some other ways, if you're thinking about it, that you might implement that? Obviously, you could just have a bool and say, "Oh, is it a joke? Are we doing with jokers or not?" You could potentially have 2 hand types. One is a non-joker hand, and one is a joker hand. What does that save you? It saves you this match logic and like this if-else block right here. So that's a little... I mean, most of the rest of it, though, is copy and paste. The reason I like having the bool is because you actually only need to do it during the parse or in the new command, and then it just figures out that the rest of it is internal to you. So even though we're not strictly in like an OO language, some of the ideas I think of object-oriented programming are actually really good, right? Is like you're basically saying, hey, give me a hand, and then I will do things for you based on that hand, right? And one of the properties of that hand maybe is the game jokers or not, right? And that will determine the hand. So I actually, to be honest, don't feel bad about that. And I do feel like it's less code than if you like duplicated the logic. The other thing you could do is potentially have jokers in all hands and have them be a value of 1. And then it would only be your parse function that would need to know whether you were playing jokers or not. And then down here you could say like, oh, do I have jokers in my hand? And if I do, then I must be playing a joker thing. Yeah, that would work, because the only time it would matter is if you actually had a joker in your hand. Would you be doing any of this special stuff, right? So the times you didn't have a joker hand, you just play the game as normal. So that does feel okay. Yeah, the part that feels the worst to me is this if block right here. And if you'll indulge me for a second, I'm going to shrink it down a little bit so that we can just look at the whole thing. This map part, I think, is pretty simple. We're literally just doing a mapping from like how many buckets are there? Like how many of each card did we get? And if there's only one type of card, then we know we got a 5 of a kind, which is the highest, and so on and so forth. It's this part that feels kind of ugly. I just want to think about it for like 1 minute, and if I can't think of anything smart, we'll just end the video. But definitely interested in your input. Like, what is it? How might you simplify this code? It's annoying that I can't keep this largest and largest value in here because it seems associated with it. Also, interesting enough, like my initial thought was, can I do this with just a straight up iter where I'm just comparing values but returning the keys? I don't know how you do that. Oh, you'd always keep the largest. Let's just think about that for a minute. It'd be like let largest value equal map iter. It would be a fold, and you start at 0, 0 because the first one would always be the largest. And then you'd have largest value, KV. If our value is greater than the largest value, then we return KV. Otherwise, we return largest value. Yeah, so that did fix it. So which of these look nicer? So this is like a quote-unquote functional approach. Like, I'm not going to have time today to solve this in Haskell, but if I was, it would potentially look something like this. Like, the question is, given a hand, which of the values are the largest? Or sorry, which of the cards are in the largest bucket? Which card has the largest bucket of cards? This actually, though, doesn't feel much cleaner. And if I remove this, I bet you I have the same issue. Yeah, see, it's now like, hey, it doesn't live long enough. So I'm just going to keep it like this for now. Yeah, I think I'm just going to keep it at this. So that was my solution for day 7 in Rust. Again, I don't think there was anything particularly hard about the problem itself. Like, I promise you there are going to be days where I will just have no idea how to solve it other than brute force. And brute force will likely not work on the part 2 of it. And so we'll just have to do some Googling for papers or for like similar problems to see how they implement it. For now, that didn't feel too tough. I mean, maybe there's a faster way to implement these sorts that someone will come with. Maybe I'll go look at the Reddit solutions or whatever and see what other people are doing. But otherwise, yeah, again, it didn't feel too tough. And I don't think I had any like straight up bugs that just dorked up the thing. So the question is why did I spend an hour on this problem? I don't know. I was mostly just thinking about ways to solve the problem. And I did struggle with this part. So if anyone has a better idea of how you might do something like this, I'd love to hear what how you would this part right here in particular, right? Where you're trying to say like, I have a hand and I want to switch the jokers to the best card. It's pretty clear that the way that you do that is you find the card with the same card that has the most count in the hand. So if there's two queens and no other pairs, you definitely want your jokers to be queens. That's clear. I think that's pretty clear that that's the solution. How you implement that, though, maybe there's a better way to do that here. Although I'm always happy to be proven wrong. Maybe there is an even better way. Although this did get the right answer, right? So anyway, I'd just be happy to hear what all you guys think about it. So here's my solution. I'll post it. You'll see it down below in the comments where you can go through it and look at it. And again, happy to see your comments, see your solutions. Obviously, I'm gonna read them. I try and post this on Reddit. I love to read if you reply to it on Reddit for the day 7. I'll look at your solution as well in Rust or Haskell or any language. I mean, if you're gonna do it in R or what is it, MathQL? What there's like I don't remember what it is. There's some very archaic languages that I will probably not quite understand, but most of them C, C++, Java, Rust, Go, all those I've worked enough with that I could look at your solution and see how you solved it. I'd love to see it, so send it to me. Reply to it in Reddit or find some way to get it to me from the comments below. I'd love to see how you solve day 7, and we'll talk to you tomorrow.